Good morning, everybody. So what we're going to do today is record a video of how the writing of the process of taking a high-speed video, making a high-speed video from individual frames recorded at different times of an event that's repeatable. So to do this, we're going to use some of the code that we started before spring break, and I'll do a demonstration with all that, but let's put the code together first. So to do that, I'm going to share my screen, which is there, and I'm going to come over to here, desktop, share. And in this case, what we're going to do is, we know what all this stuff is, so I'm going to get rid of the void setup comments. And I'm just going to start in with a setup of this particular program. I'm going to call this April drip movie .ino, and these are some just the title of it. And as we go through this, what I'm going to do is I'll write it without comments, but I'll put all the comments in a full file on the side here, so you can download that whole file. Okay, so we're going to have to put together a whole bunch of variables to make this process work. And it might seem like there's too many of them, but as we go through it, you'll start to realize that it'll make sense. As we do this, once again, I'm going to leave the comments out, and I'll put the comments on a full Word document on the side, so you can download those and look at them. I'm going to have you download the program and write a simulation that'll change diodes, LEDs, to blink on and off, and to verify the program. And then I'm also going to have you compile the actual images at the end. So to get this going, we're going to have to tell it how many frames we want. And so this is just an integer. I'm going to call this n frames. When I start this out, we're going to have 100 frames. And of course, by habit, I really want to put comments in here, but I'm going to speed it up and let you guys put your own comments and read the comments from the attached sheet. We're also going to have a frame number, and this frame number is going to be, we'll start it at 0. And then I'll tell you what frame we're taking as we go through and make this movie. And we're going to start with 100 frames. In reality, I may be able to do 150 or something like that. But this is a good place to start as we start putting the program together. I'm also going to have an integer here for the movie delay start. And this is going to be, I'm going to start it at 200. And this is the time that you're going to have to figure out for yourselves. And it relates to where the flash is going to go off after the drip is started forming. So after the drip starts to fall, what's the time delay for you to set off your first flash? And when we do this, we want the drip to be just above the surface of the water. So we can use the mechanical equation, distance equals 1/2 AT squared. Is actually distance equals 1/2 AT squared plus the initial velocity times the distance it falls. But since the initial velocity drop is 0, we can just use the distance equals 1/2 AT squared. Come up, and we solve that for the time. Last time I did this, it was 200 milliseconds, but we got a different setup here, so I'm going to have to time that out and do a calculation to figure out what it is actually at the beginning. The next variable I want is another integer here, and this is going to be a movie time increment. And this is going to be how much time in milliseconds um, between each frame. Yeah, there's my comments. Like, old habits hard to kill. So this will tell us if we take one picture, next time we're going to take one picture 2 milliseconds later. And in the end, we'll have each of these pictures a little bit of time difference, and they'll be strung together to make a movie. Remember, this works really well to simulate a high-speed camera with an event that's repeatable. And we're going to hope that this water drip is quite repeatable. Next, I'm going to have another integer here. I'm going to call this the drip LED. And what this is it's going to be on pin 3. And this will tell me when the valve is open to make the drip. And this is a great way to help me see what's going on, help me check the programs, and to make sure the circuit's working correctly. So that's that visual feedback from an LED, which is really nice. We're also going to have a constant integer here, and a lot of these constant integers are going to be input buttons or other LEDs. But in this case, we're going to have a constant integer, and this is going to be a button, a pin, and this is going to be on 2. And this is a button to start program when button goes to 5 volts. So we're going to set up a typical button. We're going to have actually a pull down resistor on it. And when the button is pressed, it's going to start this whole program running. The next thing is another constant integer. And this is going to be my dripper. I'm going to just put that on 8. And that's where my drip is going to be made. From pin 8 is going to control the read relay to control the solenoid that's on the drip valve and make the drip. Next up is another constant integer. And this is my flash pin. This is going to be on pin 9. This is pin 9 is going to control an opto isolator, which we've done a number of times in class, to set off the flash. So that should be pretty straightforward. Next constant integer is my camera pin. And this is going to be on pin 10. I'm going to have the camera set to bulb mode. I'm going to open the shutter before the drip goes down and gets to its timing where it needs to be, and then set off the flash. After that flash has been set off, I'm going to close the bulb, and I'm just going to keep this in a dark room and let this process cycle until the movie's complete. And I'm going to have a little integer down here, which is going to be called button state. And my button state is going to equal 0 initially. The whole idea of having that button state is it's going to read the value from that push button. And if it goes high, then I'm going to execute a loop. Next, I'm going to have another constant integer, lots of constant integers here. This particular constant integer is going to be the open time. And this valve, I just spent a bit of time this afternoon tuning up this valve. What this valve is it's open for 98 milliseconds to make one nice drip. So time to keep valve open to make one nice. And that's in milliseconds. So it does respond pretty well. We're gonna control a pulse for the flash, and this is going to be another constant integer, and this is going to be my flash trigger pulse. In our world, I think this particular op amp likes 3 milliseconds. This is going to keep flash in high to make a nice pulse. So we're gonna have a flash pin, and it's gonna go high for a certain amount of time, and then it's gonna stay for 3 milliseconds, and it's gonna go down. So that nice 3 little millisecond pulse, probably can get away with 1 millisecond and probably a little bit nicer, but we're gonna leave it at 3 milliseconds and hope that that works out well for this flash. We'll test that out and see what happens. If it's different, I'll let you guys know. And then we're our last variable here, constant integer, I should say, is our settle time. And this is the time for, because remember the water is going to hit this little tray of, the little drip is going to hit this little tray of water, and it's going to take some time for it to settle down. If you keep hitting it before it settles down, it's not going to be exactly repeatable. So we're going to let it settle down. In our case, we're going to let it settle down 4 seconds. So 4 seconds is 4,000 milliseconds. And this is just time to let water settle down. And now we're pretty much, those are all our variables. We can come down here to our void setup, and our void setup is pretty straightforward. I've got a bunch of pin modes. How many of them? I think I've got 5 of them. So pin mode, our first one is going to be our button pin, and that's going to be an input. And we got a number of these. So let's just make a couple of duplicates. At least that. And you're like, oh, wow, you got all those pin modes. No, I'm going to change those values. It's just because we've got a lot of pin modes that we can do things with here. The next one is a dripper. Pin. And of course, that's an output. Matter of fact, they're all outputs. So I'm just going to get all these to outputs. After the next mode, after the dripper pin, will be our flash pin. After the flash pin, our next output is our camera. And we've got a drip LED. And to help us debug everything, we're going to use this serial dot begin. And we're going to send it at 9600 baud. And of course, there's some problem here, and that serial is not a capital S. There it is. So that completes the first part of the code. Now we're going to get down here into this loop that's going to go through. It's going to start with hitting that push button, and it's going to go through this big loop every time it hits the push button. That means that I'm going to be changing this value, and the value that I'm going to be changing as each time this loop is executed is that movie delay. So I'm going to first start out with saying the movie delay start is equal to the value above, and the value above that we started with is 200 milliseconds. I should probably have a variable in the top that I grab, I come back down and have a second variable that changes in this loop. But I'm going to have to, if I change that value at the very top, I'm going to have to come down and change it here in this code. So it's something to keep an eye on. The reason I did that was just to keep it easy at this point in the code. Um, I probably should have a second variable for that, but I feel like I've already got too many variables. So next thing we're going to do is we're going to look at the button state, and that's going to come from a digital read. From our button pin. And that's going to come back, and now we're set for really the meat of the program. And we're going to say if button state is exactly equal to high, and I'm going to say equal to high is two equal signs. That's asking the question, is it equal? If I use one equal sign, it's going to set it equal to a high. And that's going to be what we do not want. So we're going to use two equal signs, and that will say, hey, let's start this giant loop if the button state is equal to high. So if this button state is high, we are ready to go. And we're going to say start this with a for loop, and the for loop is going to tell how many times this chunk of code is rolled through. And I'm going to say this with a for statement, and the for statement is going to be my integer frame number is equal to 0. So I'm going to start with a frame number 0. Frame number is less than or equal to n frames. That's my maximum number of frames in the movie I'm going to make. I'm going to take the frame number, and I'm going to say plus plus. That means each time that this line of code is run through, it's going to add 1 to the number of the frame number. And I'm going to send that value to a serial port so I can kind of verify what's going on with that. So I'm going to end that logic statement, and here we go. So every time that this takes place, these steps are going to happen. The first one, digital write, my dripper pin high. So this basically open water valve. The other thing I'm going to have in here, a little surprise that I sneak this stuff in. I'm going to have another digital write here, and this is going to be drip LED, and that's also going to be high. So I'm going to turn on that LED to tell me when that valve is open. And sometimes the valve doesn't like to open. Sometimes it can get jammed, but it's nice to have that LED there to know what you're doing. The next thing, I'm going to have a delay. And this is that open time. How long is my open time here? I want to change that in the very top part of this. In this case, that I just checked, it's 98 milliseconds. It's going to be different for every single valve you use on these kinds of projects. Something that you just have to check out. The next thing is the digital write. I'm going to take that dripper pin, and it's going to be low now. That means I'm going to turn off that valve. I made that beautiful drip, that one perfect drip. It's going to leave the dripper, and it's going to come down. And what I'm going to do next is I'm going to take that LED that tells me that that thing is turned on. I'm going to turn that LED off, turn it low. So that turns off the LED. So that makes that perfect drip for me. The next part of the code is we're going to digital write. Camera pin high. So we're going to open the bulb camera, and I probably should have a delay in here to save some exposure and stuff like that. But at this point, I'm going to just open the camera. I'm going to do this in a dark room. I'm going to open it on bulb, and I am going to start. Well, I'm going to just do the delay. And what this delay is that movie delay. That movie delay start will wait a certain amount of time for the flash to go off. And then this is going to change by an increment. So at the end of this giant for loop, I'm going to add a bit of time to that. I'm going to add that step frame. The next thing I want to do is I'm going to use this digital right a whole bunch of times. So I'm going to just probably not do that. Fix that. We're going to come down here, digital right. Once again, I'm going to do some things with that flash pin next. So it's going to flash in high. I'm going to delay. How long am I going to delay that time for that flash trigger pulse? It's just a little bit of time to keep that pulse high, nice and a nice 5-volt pulse to trigger that opto isolator for the flash. And then what I'm going to do is I'm going to digital write that flash low. So that makes that nice pulse for me. By the way, that should all be capitals. And then, since we've made that pulse, everything's good. I'm going to, because now we've taken our picture, that flash is going to make the exposure. So I'm going to take this line of code where we turn on the camera. I'm going to bring it down here. And I'm going to turn off the camera right there. That will shut the exposure, shut the shutter on the camera. And now I'm going to do some stuff with some of the logic with that. I'm going to say movie delay start is going to equal this. So I'm going to say my new movie delay start is going to equal my old movie delay start plus my step increment. And this is my movie time increment. So it's going to increase by that increment. If it's 2 milliseconds or 1 millisecond, we can do some calculations to figure that out. Now let's put some stuff in here to help us figure out what's going on with the program. And this is serial.print. And I'm going to have it do some stuff like frame number equals, and to do this, I'm going to say, hey, print this to the serial port, and when you do this, I'll be able to see what's going on. I'm going to use serial print a whole bunch of times, so I'm just going to copy this down. The next thing I'm going to serial print is that frame number. What is it? Show it there on the screen. The next thing I'm going to do is I'm going to put a little comma to space the next value that I'm going to show on the serial port. The next thing I'm going to send to that serial port is movie delay start. It'll tell it time increment is going to grow. So this will be that movie print movie delay start equals something, whatever that value is, it's going to print in. And then there's our serial print one more time. We're going to come down here and we're going to say, hey, what do we want to serial print at one last time is we're going to say, hey, show me that movie delay start time. And as I do that, do a new line. So that should make everything. So that's the loop as it comes through, but I forgot one thing. The last thing I need to do here is I need to let that water settle down. So that needs to be the settle time for the container and give that water time to settle down so it can loop back and take the next picture. So that's the program. I'm going to put this in a little Word file along with this video, and I'll show you the circuit. The circuit's nothing that you guys haven't seen before in lab class, and we will be onward into making sure everything is going. Closing the program here, everything should be fine. We can check it, and away we go. Thanks for watching. On to the next part.